Hi
I'm ready.
everyone and welcome to Azure Serverless Day. Today we'll explore the seamless integration possibilities that Azure Function offer with combination with Ballerina Azure Function Microsoft Serverless Compute Service, which allow you to run event-driven code without worrying about infrastructure. And today we have none other than Jaya Kumar with us. Today, he'll talk about serverless application development with Azure Function. In this session, he'll cover the basics Azure Function, how you can create them, deploy them, and the best practices for building serverless application using Azure Function. Hi, Jayakumar. How are you?
Hi, Shatak. I'm fine. How are you?
I am also fine, and this virtual stage is all yours. Now you can present your screen and start with the session. Thank you.
Sure. Yeah. Thank you. Yeah. Let me share the screen.
A note for the audience: if you have any question, any doubt, you can ask in the comment section.
Yeah. Hope you are able to see my screen.
Yes.
Yeah.
Yes, you can start here.
Okay. So the slide. So yeah. Thank you. Hello everyone. So yeah, welcome to the serverless day. So thanks for spending weekend on this to learn something new. Uh, yeah, so let's get into the topic. So serverless application development with Azure Functions. So the name itself states that we are going to see something how we can do our app development with less need of the servers, so that we can just only focus on our actual code. So for that, we are the resource that we taken from Azure will be Azure Functions. So before we get started, I will give you a slight intro about myself. So I'm Jay Kumar Balasubramaniam. So I work in Kongsberg Digital as a senior development engineer, and I was a Microsoft MVP alumni for Office 365 development and a certified trainer and a developer and frequent speaker and blogger. So here are my social media handles, which you can get in touch with me for any queries. Okay, let's get into the agenda for today. So yeah, today we are going to see the serverless computing and what is serverless computing and what are the Azure functions. So different types of triggers and the event-driven architecture that is used in functions and the application lifecycle management of this Azure function and a small demo of the same. Okay, the serverless computing. So yeah, as I said, the serverless computing, the name itself states that it's a kind of a model where the cloud providers, like in our case, the Azure is Microsoft. Azure is our cloud service provider. If we go to there, a lot of cloud service providers like Google and Amazon. So everywhere the serverless concept is like the cloud provider will be managing your allocations of your resources. What are the computing things that you are going to use? What is the operating systems, and what are the memory, and how do you scale the memory when the overload comes, and what is the configuration of your system or operating systems that you are going to use? Everything will be managed by the cloud service provider, and in our case Azure will be managing that. So as a developers, we no need to worry about anything, any of these things like the managing the servers or the managing the infrastructure, ensuring the network or the availability of nothing. We just don't need to worry. Our only focus is on to writing the code and implementing the logic and achieve our core business value. So that's a major benefit in serverless computing. So the top benefits on this is like it's a reduced cost because you are not going to own anything on yourself, and you're just going to kind of rent it out. So whenever you want it, let's say you are going to run your certain piece of code, you are going to use the serverless computing from Azure function, and you will just run it for, let's say you're running it for 2 minutes or 1 minute, and you're going to pay only for that. that computing resources will be consumed. So only for that 2 minutes will be paying. So that's kind of reduced cost, and it increases the scalability. You no need to worry anything about how whenever the many loads comes, how you are going to scale the service, and how you don't need to worry. And also you can easily expand it to the other peoples, and you can easily expand your customer bases when you start using this, because the scales are under automatically managed by the Azure, and which it in turn helps you to move to the market for the applications in a faster and efficient way, because you're just going to focus only on your code. So that these are the top benefits discussed. So there is no infrastructure management. So with the serverless platform, so you just simply focus on developing your code and just deploying it to your code. So there is it just runs with the high availability and the scalability. You don't need to worry about the other stuffs on managing the stuffs. And the dynamic scalability, so the infrastructure itself dynamically scales up whenever you get more workloads. Let's say you develop it for 100 users who can use it. Maybe certainly you got a spike of, let's say nowadays in India we get big billion days Flipkart. So at those times you will be having huge number of hits to your application or your certain piece of code which are it is running. So in that time you cannot go and do at that time that okay there is you cannot monitor, sit and monitor, okay I'm getting so many hits, I need to increase my storage, or I need to increase my computing power, or whatever. You cannot do at that time. So because the people are already start coming, so in that case you it will automatically scale on its own, because we due to the dynamic scalability. And you can configure that at what time you need to increase the scale and what time you want to decrease the scaling, because uh, if the configuration is always at the top edge, then you will be charged more, right? So whenever the utilization or usability of the application comes down, then you need to reduce your configuration as well. So that's called scale up and scale down. So this is also automatically possible. You no need to worry about managing those things again. And it's faster time to market. You, as you are focusing only on the writing this certain piece of code, you'll be easily taken to the market with because we don't have any of the worry about the other infrastructures. And we just focus on how we can achieve our business core values and how we can satisfy the requirement. So let's come into Azure Functions. So Azure Functions is one of the serverless computing service that is offered by Microsoft Azure. There are a lot of other serverless uh, computing services available at Microsoft. Let's say Logic Apps is something that is, it's kind of a no-code platform. You don't need to write any code. You just drag and drop your components, and you with couple of button clicks you can implement kind of an automation. That's again another serverless compute. You are not going to worry about anything in the background here, in that you are not going to worry anything about the code, but you'll be achieving your automation. The Azure function is another serverless computing concept. It involves certain pieces of code, but again it's the backend of that, how the data is moved out of this Azure function, how the data is coming to the Azure function, and how the data is managed in the backend, how your services are managed. You don't need to worry about that. Everything is done by the Azure, and it's majorly an event-driven concept. The Azure function, it's a event-driven based computing platform which uses any kind of programming language of your choice. There are a lot of programming language options available. Let's say that it's an Azure function, so you can it's with Microsoft, you can only code with the .NET or something related to Microsoft tech stack. It's not like that. You can code in most of the all the possible languages that are recently available. So it just lets you only focus on the business logics. So as I said, that data, how the data is comes in, that is managed in the triggers, and how the data is going out, you can manage it with the bindings as well. So I will show you how these triggers and bindings are managed as when we show the demo of how this Azure function works. So as I said, the Azure functions develop, you can develop in any of your preferred languages. So it's not only with It's not only with your .NET. You can do with the Node, or you can do with your Java language, or if it's a PowerShell, that is also available. Or if you want to do any Python, or those things are available. So it's not only restricted to Microsoft or Windows. You can even configure this function that can run on Linux machines as well. So that kind of flexibility you have with Azure. Again, you are just going to focus on your code by using any of these programming languages. Here, I just showcase only five things just for the presentation purpose. But maybe when I show you a demo of creating the Azure function, I'll show you what are the other possible languages that are available. Yeah, so as I said, it's an event-driven based architecture. So Azure Function works in any things that for that to work, we need something to be triggered, right? Let's say if it's not a server, if it's an app service, or if it's a logic app, as I said, some input has to come to the specific piece of code to trigger that, to execute that. So this Azure Function is completely an event-driven based architecture. You write your code, your events plus data will come in. Your events create some data, and it will push some data to your Azure function, and it will generate some output, and you will be returning that output either to your code, or you can post it to some other Azure resources. Anything is possible. This combination is called Azure functions, code plus your event data. We can see here in this picture there are a lot of approaches of event driven approach. Let's say that you have parallel asynchronous thing, and you have a fan infinite concepts. That means you give one, you have five Azure functions running. One Azure function is dependent on other three Azure functions, and output of one function will be an input of the another three function, and that output will be an input to the another function, which will give you a combined result. There are different approaches available to execute this event based executions by connecting one Azure function with other Azure function, so that you can get the best results. And with the same, you will be having an built-in application lifecycle management. So as I said, the triggers and bindings is that's as I said, the function it starts with the triggers. So what comes into the how the data comes into the trigger, and what data comes into the trigger, and what triggers the Azure function. Everything is in the you can manage within the Azure function itself. And the output bindings, let's say that you want to return some data to your storage container, or you want to return some data to your Cosmos DB, or you want to return some data just as an API result. Everything is possible by managing your triggers and bindings within the functions lifecycle management itself. Let's say that if you want to if you okay, Azure function, we have written this much. We are talking about the triggers and bindings. Is it possible that only it can be used as triggers and bindings? Some can we use this to write some piece of API code? If you are a developer for who's working for some well, maybe in 1 year or 6 months, you will be definitely come through a word of API. Yeah, API is kind of an application programming interface which connects to two different systems. Let's say that you have you are using any kind of application. You have some database. Okay, to access something, get some data from your database and to display it in your either in your phone or your web, to connect between these two, there will be definitely be an API layer which establishes connection between your database and returns the result to your front end. So that is that we can develop API in any language. Anything is possible, like C# or Node.js or any languages we can create the APIs. But is it possible to create the same in Azure Function as well? Yes, it is possible, because we have a specific trigger for that as well. You can use Azure Function as API also. Maybe it let's say that APIs will be frequently used, like there will be some APIs. Let's say you upload a profile picture. Profile picture we may not upload frequently, so that there will be a less usage on that. But let's say that you have your dashboard and you have an API for that, you'll be frequently using that API. So that API you will be having a frequent usage. So is it possible to use both the things, both different scenarios in your Azure functions? Yes, that is also possible, and we have a different hosting plans to achieve all these things. So let's come into the hosting plan of Azure function, so which will give you some more detailed information. So yeah, there are currently there are four different hosting plans. Out of this, one is in preview, the container apps. So the consumption plan, so as the name states, the consumption plan is the default hosting plan, and it's what you're going to pay for your usage. So let's say that you use your Azure function, as I said, maybe the profile picture upload. You having very limited usage. So in that case, you can go with the consumption plan, or you have very you will not use the specific function every time, but it's based on the requirement or based on the hits rarely used, or you can go with the consumption plan, so where you will be paying only for what you use. It also scales automatically, everything is scales automatically, even during your high load, also it will be loading automatically, scaling automatically. The premium plan, so let's say that you have your function, it's keep on running, it runs continuously and or somewhat near continuously. Your code, let's say that your code needs to run for the longer time, because in consumption plan we will have some restrictions that your function app can run for a certain period of minutes, because it's a consumption based plan, right? If it's run for a very long time, like 1 hour or 2 hour, you will be charged more. So as per the plan, there are some restrictions. You can set the restriction limit as either 10 minute or 15 minute or 20 minute. You can configure that as well, based on your function workload. Then it will run only for that time. But let's say you want something to run continuously and always available, and it will be keep on continuing continuously, you can go with the premium plan, so which gives you a flexibility to run your function for a longer time than the consumption plan. And app service plan is the next one. So for the best long running scenarios, you can go with app service plan, which will work based how your Azure App Services work. Because when you create your Azure App Services, you'll be creating app service plans, and the same app service plan can be used for this also. So you'll be having a dedicated servers and dedicated storages, dedicated capacities, dedicated virtual networks. Everything can be you can create using the app service plan, and you can tie that up with your Azure function. So by that way, you can use the you can run your Azure function for any longer time also. And the best option to run the long running functions is durable functions, where you can durable functions is it's really meant to use execute the long running functions. And the container apps is the next option that is available in a preview mode, to use the containerized based thing to use your to host your Azure function. So let's see a small piece of demo how to create the Azure function using the portal and using a development environment, and we'll see some basic triggers, how this can be achieved and how faster we can, as I'm telling from the initial, how faster we can move to the market by use of Azure function. I will show you something in real demo. Okay, let me share the screen once again. I'll share my entire screen. Yeah.
Hello.
Yeah.
Yeah.
Yeah. I'm sharing back my screen so that you can. Okay. Hope you are able to see my screen again now.
Yes, yes, yes. I can hear.
Yeah.
See.
Okay. So now I have already created a service. Let's say, let me go to Azure Function app. So in the Function app, so this is the place where we are going to create our Azure function. So we just need to create a function app first in your, if once you log into Microsoft Azure, portalazure.com, then you can search for the function app. Then you come here and create a function. You, in what language you are going to implement your Azure function, you are going to decide it at that time of creating the Azure function app. And on under the Azure function app, you can create a number of functions. So let's see what are the languages that are available for us, and let's see what are the platforms that we can deploy. So I'm just naming it dev test j2. There is some, yeah, okay, this is available. And the runtime stack, as you can see here, you can run in .NET, Node, Python, Java, PowerShell. If you select PowerShell, you will have different versions as well. You can decide the version also, in which version you want to run your execute your function. Let's say .NET, you have 4.88, mostly whatever the latest version that is available, and you choose the region. Now I'm going with the .NET. So I'm going to stick with the 6, as it's the long time support version without isolated mode. So let me stick with the 6 LTS. And as I said, you can go with the Linux and the Windows. And here you see the consumption plans as the other one, the container app based hosting plan, is in preview, so it's not available for this one because I'm using a developer mode, so it's not available. But it's in preview. Once it becomes general availability, you will have the another radio button option over here as well. Now the consumption plan, functions, and the app service. This is the premium plan and the app service plan. So now I'm going with the consumption plan because I'm just creating it for a demo purpose. I will not have a long-term usage. I will have just short-term usage, and I'll just run it only when I show you the demo. So I go with the consumption plan. Next, storage, and by default, every function will run with the help of the storage, and you need storage account. It will create it, or you can create use your existing storage as well, and you can leave the other things. But you just be focused on the monitoring part, because it will default create application insights. That will be an additional charge for you. If you want, you can use it, or you can the application insights is really helpful when you want to monitor some of the logs, how your Azure function is behaving, and what is the throughput and what is the success rate. Everything you can monitor. If you don't want, you can just skip it, then review and create. So once you create, it will just validate whether the options or the fields that you fill is valid or not, and you have the enough permissions to create it. Everything it will validate, and then it will click the create button. It will create it. So I will just skip that part because that will take another 3 to 4 minutes. So I'll just skip that part and let me move to the function which I have created already. So let's come here. Yeah. Okay, so this is our Azure function. You can find the settings that are mostly related to your app service. Let's say you would be having the configuration, you'll be having the deployment slots, and you'll be having your custom domains mapping. You can scale in, scale out. As you see, you can have the app service plans, and you can have the cost policies. Most of the options that you see for app service, that will be available in here as well, and the publishing profile also you can get. The one major addition onto this is your even is your functions. That functions you can see in the overview page. You can see in the overview page at the bottom, you can minimize the session shares. There is an option. So let's say if I delete this, I'll delete this function. Now you see, you can create Azure function. For now, we just created the function app, and we are going to create the function. As I said, function app can be an umbrella for multiple functions. You can create the function in multiple different ways. You can create it using the portal itself, and yes, you no need of any development environment also to do your code. You can just do everything in your Azure portal itself. You can write the code, and you can test the code, and you can deploy everything in your portal itself. You can do. But if you want to create it using Visual Studio, that is also possible. I will show you how to do that. And other it is, let's say, the CLI, or you can use the default Azure CLI Cloud Cell also. You can use to create the Azure function. For now, I will go with the portal. Then I will show you in the VS Code as well. Let's say create with Azure portal. Yeah, it is coming. Yeah, this is our first part. As I said, in the life cycle, that triggers. Every Azure function is working based on the trigger. Even the API, if you want to create it as an API, which I said, with some example of database and your front end app, that also works with based on the trigger. But for that, you'll be using a HTTP trigger. Your HTTP trigger can be converted as an API as well, and there is a timer trigger. Let's say if you want to automate something and you want to run something on daily basis without a trigger. Let's say you have a queue storage trigger. Whenever something comes into the queue, uh, this function will get triggered and your piece of code will run you and you do some actions. And same with service bus, or let's say you have event hub. If you something comes to the event hub, you create the trigger. But let's say you don't have any of the thing, but on daily basis you want to run, let's say it's kind of a timer jobs, or you want to monitor something on daily basis or monthly basis, or for every hour, anything you can achieve by using by setting the timing. Let's say you do in the earlier or older case, let's say it is an equivalent to a Windows service which you install in your Windows machine to to automate some of the job, or you want to send out a daily reminders. Let's say that every day 9 o'clock you want to send out a birthday wishes. Let's say you are in an organization, you want to automate something, and you have the data available in any store like uh, database, SQL, or if you have an Excel sheet uploaded, or if you have any SharePoint, or if you have any Azure storage tables, you have, or any NoSQL data with Cosmos DB, anything you available data is available, but you want to monitor it on daily basis and check whose birthday is today and send out an email reminder for every 9 o'clock. You can use the timer trigger and the queue storage. And these are the other triggers. You have a lot of triggers you can just explore when you get the time, like SQL input, and if you have the durable functions, and it can be a Cosmos DB trigger, any data uploaded to Cosmos DB or any data uploaded to queue, anything you can use. Now simply I go with the HTTP trigger because that is with the concern with the time we can use the HTTP trigger. That will be uh, easy to showcase. Let's go with the HTTP trigger. And again, you see the option, multiple options. I go with the development portal. Let's create a HTTP trigger. Let it create. It will not take much time. It's created now. So you can see the code plus test option. This is where I said you no need of any IDE to do your development. You can do your code right away from here. Let it open. Yeah. Okay, so this is a pure .NET code, and you can see if you even if you create in VS Code, you will get the same view. So if you, the only thing is you may not get the real compile time thing, so that you get to know what is the data type and what is the tightly binder things. All those things you may not get in the when you do in the portal. But yeah, still it is a pure same .NET code. If you are aware of the other syntaxes and the keyboards, you can directly use this. It's a sample function. Let's execute that. Okay, forget about whatever the logics that you want, you put in here. But let's say how to test this and how to run this and how to use this. Okay, here you can see a run and test option. So you can test this application right away from here. And yeah, hope it is focused now. Test and run. And let's say that you want to focus on you want to see the logs, how your function is executed, or if you have any errors captured, you can use this app insights log or the file system logs based on your configuration. You can use this also to see the logs. I'll show you how this is also working. Let's test this application first. I mean this function first. As you see, I have not done any piece of thing for the infrastructure. I just created the function app. I just created a function called HTTP trigger, and I have some default code. I will change this code for my certain piece of business requirement. That's a secondary thing. But only with this function we don't need to worry about any other infrastructure. Just let's focus on our code only. Let's say this is our code, and you can see this code is working based on the query string value name that we pass. Maybe I will pass name here. I think maybe we have this. Let's see whether this will work. Yeah, If it is not available in the question, it will take from the input body. You can see here in the input we given this as Azure, but we give this Azure. So it takes the Azure, and you can see in our output just prints hello Azure. This is a HTTP trigger function, just a sample function like a hello world application you can think of. So let's change this input, and also you can see in the logs, you can maximize the logs. Your function got triggered, and it just executes. Your function got triggered, your output is also printed. Everything you can see the logs, how the execution pattern of your function here as well. Even if you run it from VS Code, you get the same logs. It is by default the file system logs will be coming even if you don't enable app insights. It's just for your temporary thing. But when you enable app insights, that logs will be there always. You can go and check. Okay, now, okay, this is everything running within the portal. Let's say, as I said, for an API, if I want to use this, or if I want to give this to some third-party application or your another application, how you can do this? How you share the URL of this? Because anything you want to access over the web, you need some piece of URL, right? How you are going to do that? With the help of function, you can just directly get the function URL here. It will be just with some default set of format. I will just copy this, and I will just add it on notepad for your checking purpose. See, it will be the default thing. Let's say demo J1, my Azure function name, and Azure websites.net is a default subdomain from Microsoft. And the API, as I said, it can HTTP trigger. It works as an API, and HTTP trigger one. That means my function name. You can change this to anything. Whatever your function name you keep, it will be change it like that. And your code. This is your security thing. Let's say that it's just because it is available in online, it you don't need to allow everyone to access that URL, right? That's why this code comes into place. Only this code, let's say if I just only access this one, it will not work. You can see the error code, 401 unauthorized, because I just put the URL. There is some authentication needed, right? That's where this code comes in. And there are different code available. Okay, I have not paused anything. You can see this is HTTP trigger, but let's pass something in the question. We have it as name, right? Name equal to Jayakumar. Hello Jayakumar. So this is one. It gets my input, and it print it. I'm just open in incognito. So with this code, it will work. Let's say that, okay, what is the difference between codes? Whether you will have the same code anytime, or there'll be any differences as well. So when you try to get the function URL, you can notice there are multiple keys available: master key, default key, and there are certain purposes for this one. You can master key is something you have access to all the functions, and function key is something this code is available only for this function. So there is different purpose on this one. You can get the keys based on that. Okay, now let's look at the authentication of this as well. As I said, it's completely serverless. So you no need to write any worry about major piece of codes. And let's look at some kind of authentication. Yeah. Let's say if you want to add, let's say that Microsoft login, I will show you this one. portal.azure.com. When we open anything related to Microsoft, you get this window to put in your username and password, which is using the Microsoft's identity platform to ensure you are a valid user, and it will allow you to log in. If you want to get this kind of thing for your Azure function, let's say if you're using that as an API, and you want to enable this some kind of authentication like this, you can add it. You have the identity provider option in your authentication section of function app, and you can select identity provider. You have these many options, either so Microsoft or Apple, Facebook, Twitter. Like if we want to log in with Facebook, you want to log in with the Google or Gmail. If you want to log in with Twitter, anything is possible. So you can use this option so that without writing any single piece of code, just by some configurations, you'll get this authentication enabled on your function app. And now let's see the configuration. So configuration, as I said, it is same like the Azure app services. Okay, I think it is taking time. Configuration usually take time because it needs to load certain things. Okay, yeah, it loads. Okay, you can see the same kind of app settings. You can configure your any of the environment variable that is accessible by all the function. You can add it up here. If you have any connection strings, you can add it up here. If you go to Azure app service, you will get the same settings. But this function runtime settings is something that decides what kind of what version that your function app is about. You can decide it here, and what is the daily usage quota and other general settings, either debugging mode or client certificates, HTTPS, everything you can manage it over here. Okay, now let's get back to the function. Let's see what are the triggers and bindings that you can use to share your output. Okay, let's go to HTTP trigger itself and see, open the HTTP trigger. In the integration, you have only very limited option of overview, code plus test, integration, monitor, and function keys. For your function keys, you can decide the key which I showed, right? If you want to remove this key, and if you, I will just renew this key. So the just showcased in public now, right? So let me renew this key. This key is changed now. Now this piece will not work. Yeah, the same with the code, but it is not working because I changed my key. Yeah, if you want to add multiple keys also, you can create it, and you can use it for different purposes. Or if it is used by different clients, you can give them each one different keys also. Let's go to integration part. Yeah, so you can see the integration where you can define the HTTP triggers and the output bindings. So the trigger is HTTP trigger because that is defined at the time of creating the Azure function itself. So you cannot change it. It is just a trigger. But if you want to give some inputs, you can give your inputs here, and this trigger will be coming to the function, and it will execute some certain piece of code, and you will have some output. Let's say this is the return type of this HTTP trigger is again a HTTP result. So you have a HTTP result by default. But on top of that, you can add another output also, output binding, so that your result will be posted to any of the bindings that you given here without writing any piece of code to establish the connection between your output and your the respective service. Let's click the add output button and see what are the options that you have. As you see the binding, they have different bindings. So from your Azure function code, you can connect with blob storage, cosmos, events, service bus, or another just a HTTP result as well, or stable storage. Send in Twilio SMS, you can use the Twilio SMS service to send SMS also. You do anything, and you can post your result over there, so that it creates a respective data in the respective in the Cosmos DB. It will create a JSON document. Maybe in the blob storage, it will it will upload as one of the blob or files, and the key storage will be created as one queue message. You can do that, and service bus, it will create one service bus message. Anything is possible. Just again, it's with just a configuration. You have your already Cosmos to be available in your system, so just click this, or if you want, click new button, and it will show all the available connection. Choose that, and what in the parameters changes based on what we select. Let's say we'll go with the storage. I think I have one storage I created. Yeah, it will ask for the web storage. Let me create a new storage. So I have created these many storages. You can choose anything. Then if you, what is the blob parameter you want to create, you can mention here in which path you want your result to be uploaded, everything you decide. Then you just click OK, then your output will be pushed to the respective output binding as well. So with that, you can use any trigger. We already see there are a lot of triggers available for Cosmos, Service Bus, Storage, and even hubs and grids or HTTP triggers are available, and the same for bindings as well. So that's what the life cycle thing I said. The one starting with the trigger to ends with the output bindings as well. Okay, now let's see something with VS Code. Okay, we are doing everything with Portal. Okay, what maybe we cannot do everything with Portal because we want to maintain some certain source control to when you come to a proper development. You want to maintain some source control. You want to maintain some versioning. Everything. Some organizations, mostly all the organizations, will need that. So let's see how we can create the Azure function in our VS Code. VS Code is most easy because it's a lightweight. Okay, just open the VS Code now. To use Azure function, you need certain piece of extensions. So you get the commands related to that. Go to the extensions and you can see I have installed Azure function as one of the extensions in VS Code. You can just install that by searching in the marketplace of VS Code, and better you install Azure account as well, so that you can connect your Azure account with your VS Code so that you can easily deploy it. Once you install the Azure function, you will get the related compatibility of Azure function in your VS Code. So as I have already installed this piece, now let me go to the command palette and let's see how we create this. Okay, we have a lot of Azure options. You can see because I installed multiple extensions. I want function here. Let me search for functions. I want to create Azure function app, right? Before creating function, we need the Azure function app. So I'm just going to choose this Azure function app, create Azure function app in Azure. Let's choose this. Sign into Azure. It asks to sign into Azure. Can I just copy this URL and paste it here because you're already signed in. Because we are going to create some function app from our VS Code itself, right? So we need to sign in obviously to connect our Azure function. Select the subscription. So I select this subscription by default. Then okay. Then enter globally. Again, the name for our function app. Or okay, you can create the function app without logging into Azure also. Let me try that also. Or let's just create the function. Okay, I think it is now in the half state. Let me open new window. Create Azure function. Okay, it's asking for a location. Let me go to my repos, personal, and the community demo and speak serverless day demo function. I just choose this folder. What are the language that I want to use? I go with C sharp. And what is the runtime it has? It will give us the option. I go with 6.0 LTS, same like what we did there. I'm just creating a function now, not the function app. So it will, we can deploy directly a function to a function app. We'll see how this is happening. Okay, now we source all the triggers that are possible. Again, let's go with the HTTP trigger. As I said, we can name it anything. I will name it as demo j trigger HTTPS. And it's just a namespace. You can leave as it is. Yeah, access rights, I go with function. Open in current window. Let's let it open here itself. Yeah, we have our demo, the same demo, because whenever you choose HTTP trigger, you will get the same code. Now we have our function readily available here. Okay, how we can test this? We can test this from our local itself. You no need to. Till now, I have not connected Azure. The previous one I demo, I connected Azure because I tried to create Azure function app, but now I just created only the Azure function, not connected with Azure, and not the Azure function app. Just a function created in my local without any connecting to Azure. As it is a HTTP trigger, you don't need any other triggers like Azure Blob Storage or something to run your Azure function. It's a HTTP trigger, so you can run from local itself. Let's run it. Okay, I think I cannot run using this one. Maybe I will run from the command prompt. Okay, yeah, I think I have missed installing some commandlets to install this. Okay, let's see. So this is our Azure Function app. I created demo JTagger HTTPS. You created and you can test it from your local itself. Okay, let me try to open in this VS Code or Visual Studio whether it works, because Visual. Okay, let it open. In the meantime, I will show you how to deploy this. Now we have our function. We just need to deploy this Azure function to our Azure function app, right? Since okay, we have, where is our Azure? Yeah, here is our Azure, and since I already connected my Azure account, it will load all our resources. Let it load. Yeah, okay. Let's go to function app, demo J function. I already created this demo function app in our portal demo. Okay. Now, if we want to deploy this function, I just create a function or the function app. This function to our function app, just come as I click here Azure thing, right click your respective function app and click deploy to Azure function app. Or you can do that with command also, because you have the command palette available for deploying function app. You can deploy using also. You can deploy your function using the, see, you can deploy to function app. This option also you can use, but I'm just using the Swiss IDE options. It is deploying it. Let's install some recommendation. It's running and deploying. Okay, let's let it deploy. Let's check here whether a function got created. It will take some time. It's deploying. Right. You can see the status here. Yeah, it's available here now. Okay. I click it off. Yeah, you can see demo JTrigger HTTPS, which I deployed from my VS Code. I just created a function and I deployed onto the existing function app. So that's easy. It is to write your code and deploy it to your serverless Azure function app. Let me open this up and run it for you so okay, see how this works. Yeah, it is deployed from my code. So it is deployed as a package. You cannot see the code here because I am deploying it from literally from my VS Code code. When you create a function in portal itself, you can edit the code here or do anything here. When you deploy it from other sources, it will be deployed as a package. You will not be able to edit the code, but you can see like this. If you remember previously when we create a HTTP trigger in portal itself, we are able to edit the code. The same piece of code when we create from function app and deploy, it just applied as a package. But still executing and testing everything is same. I just copy this and I will execute it here. See, the same piece of code works. So yeah, this is all an overview about what is a serverless Azure function, how we can do the development and deploy it into Azure portal. And we have covered some of the options about hostings and what are the different hosting plans available and what is the triggers and bindings, how you can do the deployment as well. So everything. So that's it for today. So hope you get some better idea about what is serverless and what is Azure functions, how we can do the development and deployment over there. So now it's time for any queries. Santak, do we have any questions?
Hi, Jay. Yeah, I
Hi.
people are saying that they don't have any doubts. And lots of hi and good morning message for you in the chat. Uh,
Yeah, I'm seeing the chat.
yep. Yeah, thank you for joining us today, and it was a great session from your end. And thank you for making this serverless team more special with your guidance. Um,
Yeah,
we
thank you.
have, yeah, thank you. Guys, we have a 5 minutes break till the next speaker will joining us, and you can also have some water because we have two more sessions left. Next, we have for Azure DevOps. We'll we have Naveen Verma with us. So let's have a quick break for 5 minutes and then come back and then start this session again. Hi Naveen. Hi everyone. We have Naveen with us. Today, Naveen will talk about Azure DevOps for IAC, Infrastructure as a Code. And in this session, we'll deep dive into the Azure DevOps for managing infrastructure as a code with tools like Azure Resources, Manage Template, Terraform, and ARM Biceps to deploy and maintain Azure resources. So, hi Naveen, the stage is all yours. Uh, can you
Thanks,
share?
Harpreet. Thanks for having me. All right, so I'll just quickly walk through the agenda of today's session. So, in today's session, we'll be having a detailed introduction on various different approaches that we can have in order to provision infrastructure in Azure. And there are multiple different options which we can leverage in order to achieve that. So, I'll just quickly share my screen as well. Just give me a moment. So till then, I'll just quickly introduce myself. I'm Naveen Verma. I'm working as the lead DevOps and cloud consultant in Ops2 Solutions. I primarily take care of all the cloud and DevSecOps related activities, primarily architecture designing, infrastructure optimization, DevSecOps implementation, security audits, cost optimizations. So anything and everything that falls under the purview of DevOps and cloud, I take care of that. Apart from this, I am a part of Azure developer community and I am the developer lead from the Gurgaon region. And apart from that, I'm also an open source contributor. So me and my team have published multiple different Terraform modules in Azure. So that would be a quick brief about myself. And now I'll just quickly share my screen. All right, so I hope my screen is visible now. So we'll quickly walk through what IAC in Azure looks like, what all different approaches do we have, and how we can leverage the power of automation in order to streamline and faster provision our infrastructure in Azure. So IAC primarily stands for infrastructure as code. So infrastructure as code primarily refers to maintaining and managing your entire infrastructure via some sort of automation or some sort of scripting mechanisms that is easy to manage and helps you provision and maintain your infrastructure in a longer run. So ideally what happens is in earlier approaches and earlier practices, we primarily used to manage the entire infrastructure or provision the entire infrastructure using the manual approach from the console or from the portal. So that approach for a particular beginner or in the beginning of any infrastructure provisioning journey, that is something which ideally we should incorporate in order to get the good understanding of how a particular service is provisioned, how you can configure various different services. However, going forward on a longer run, managing everything manually becomes a bigger challenge. And in the current times of automation, managing something manually becomes a pretty big overhead for the entire team. And in order to address that challenge of manually maintaining the infrastructure, we have something called as infrastructure as code. So there are certain challenges that we encounter while managing a particular infrastructure manually. First and foremost is you do not have the visibility of who is making what changes in your environment. For example, I have two team members in my team and both of them are provisioning the infrastructure manually. Now, if one person deletes a particular resource, I will not have any track or any audit trail of who deleted this particular resource. So managing the infrastructure, getting that visibility, adding the governance becomes a bigger challenge in the longer run when you are managing your entire infrastructure manually. And this is what we'll be addressing via the infrastructure as code approach. So it's the same ideology that we just discussed. So we are managing and maintaining our entire infrastructure, our entire cloud infrastructure, or be it your on-premises infrastructure in the form of code. So it helps the entire team collaborate more efficiently. Plus, it optimizes the way you provision and manage your infrastructures. So there are multiple importance when we provision ISE in our cloud computing model, starting from scalability, deployment speeds, consistency, DR, and cost control. So we'll just quickly walk through all these items as well. So when we talk about scalability, right? So in today's design, we primarily focus on a system that is scalable enough that can handle or cater to any fluctuating demands of traffic. And if I am managing something manually, right, then I constantly need one person in order to scale up or scale down the environment in order to cater to the fluctuating needs of the traffic. So if I am managing my entire infrastructure using a code based approach, then I get complete control on how I can manage the scalability of my environment. With just a single operation, I can scale up or scale down my entire infrastructure without any manual interventions. Speed of deployment, definitely the speed of deployment increases because you have everything managed and everything in your repository with you, so you can provision, deprovision your environment, your infrastructure whenever you want. So that speed is incorporated in your system, which will in turn help you provision the infrastructures at a faster pace, because of which your teams would be enabled to perform their operations at a greater speed, and finally your time to market will reduce. So speed is another primary component that incorporates inside our ISE approaches. Consistency, as I mentioned previously, right? We do not have that governance. We do not have that visibility. So the consistency is lost when we are managing our infrastructure manually. That means if anybody is making any change, we do not have the visibility who made those changes and why. So in order to avoid those inconsistencies, we go ahead with the approach of code-based infrastructure. So that way we will have a clear understanding, a clear visibility of why exactly a particular change was made. And we will have the entire audit trail with us as well. Then moving on ahead, we have something called as disaster recovery. So disaster recovery is the component which is very crucial in any production grade environments. So whenever you talk about disaster recovery, that means your system should be up and running in case of any disasters as well. You should be well equipped, you should be well prepared for those rainy days. And in order to provision and in order to prepare yourselves for those rainy days, DR activity is something which is very crucial. And DR activities are something on which the current organizations in the present day are giving more focus on. So I have my primary infrastructure up and running, but I should have that speed where I can quickly switch on to my secondary infrastructure if there are any issues in my primary infrastructure. And the final component is our cost control. How cost control comes into the picture is whenever you are provisioning something and you have consistency and traceability of what you are provisioning, that means you will have a clear visibility of what your expenditures are going to look like. For example, currently I am provisioning my infrastructure using any code based approach. For example, I'm using Terraform. So using Terraform, I will have clear visibility that, okay, I have these many modules, so this is going to be my approach. So I know these many resources are going to run in my environment. That means I can predict, I can analyze the expenditure which I would be making in order to provision that infrastructure. However, if the similar approach is proceeded in the manual format, then we will not have that clear visibility of what resources the other team members are provisioning, which can in turn surprise you with some unwanted costs. So that is why cost control is also a factor when we are working in the IAC approach. So now moving on ahead, we have the IAC streamlining the infrastructure management. So as we were discussing, right, IAC streamlines your entire approach of how you provision your infrastructure. So I'll just quickly open draw.io as well so that I can show you some visuals of how things look like. All right. So whenever we are talking about streamlining the entire process, right? So whenever we were manually maintaining our infrastructure, so let this be our infrastructure. Just add some shapes here for Azure. So for example, this is one infrastructure. So this is infrastructure one, which would be managed manually. And this would be our infrastructure two that would be managed in an automated fashion. So for example, in both the environments, we are provisioning certain set of virtual machines. So let's say we have VM 1, 2, 3, so on and so forth. So let this be user 1 and this would be user 2. So now as you can see, user 1 is provisioning one set of virtual machine, user 2 is provisioning another set of virtual machines. Now in this scenario, both these users do not have the clear visibility of who is provisioning what resource. All right, he has provisioned VM1 and he has provisioned VM2. Now they do not have any clear visibility that user 1 has created a VM already or user 2 has created another VM in the system. So there is no consistency here. So the process is not streamlined. So at any given point of time, if I ask user 1, user 1 will only tell me that there is one VM which has been created. However, if I ask user 2, the user 2 will tell me there is one VM created. However, in total, there are two VMs that are being created. So there is no streamlining in the process and there are no consistencies. However, when we are dealing with the automated infrastructure provisioning, right? So we would be having some sort of governance, some sort of tracking in place. So if I say this is VM1 and this is VM2, so now in the case of automated deployments of the infrastructure, when user 1 is creating a particular instance, so user 1 creates the instance and user 2 will also be leveraging the IAC approach in this scenario. So while the users are leveraging the IAC approaches, both the users will have visibility of what exactly is present in the system as of now. And whenever both the users would be interacting with the environment, they would have a clear visibility of the entire ecosystem, the entire landscape, which will help them provision the resources accordingly. Right? So this is the streamlining that IAC brings into the picture and how infrastructure as code can help the team collaborate efficiently. Now in this case, when user 1 has created the IAC module or the IAC component for a particular resource, now user 2 can leverage that User 2 can also share the code. So here, let's say this is the IAC code, and then we have two users, user 1 and user 2. And both the users can interact with this code base. Now in this scenario, both of them will be having the visibility what components are there in the environment, what the other team member is working on, and which in turn will streamline their process of infrastructure provisioning. So this is how IAC helps in terms of streamlining the provisioning of your infrastructure. All your team members are on the same page. They know what they have to do. They know what is being provisioned, what is already there in the system. So there are no discrepancies in the system. And that is how you will get a good visibility, a better clarity on how your system is working. All right. Plus, as I mentioned earlier also, whenever there is any change in the system, the entire team would be able to identify who made the changes, when the changes were made. So they have the complete track of the system. Now, we will talk about some of the approaches that we can use in order to automate our infrastructure provisioning in Azure. Now, Azure provides a good amount of toolset in terms of provisioning the infrastructure. That means you have multiple different components which you can utilize in order to automate your infrastructure provisioning. So Azure provides you Azure Resource Manager templates, that is ARM templates. I'll walk you through all these components one by one. Then we have Azure CLI, then we have PowerShell, then we have Terraform, and then we have something called as Azure Bicep as well. So Azure Bicep is more closely related to the Azure version of Terraform. So you are getting 5 different approaches in which you can manage your infrastructure via code, or you can automate your infrastructure. So all these 5 approaches can be utilized in order to provision your infrastructure. So first of all, before deciding on which approach you have to follow, you have to analyze which approach will be the best fit for your environment. And based on that, you can choose any of the 5 approaches. Now all these approaches are pretty powerful in themselves and packs a good amount of features. However, there are certain set of limitations to these approaches as well that we will be discussing now. So first and foremost component that you will see is the Azure CLI component. So what Azure CLI will do is Azure CLI allows you to provision your infrastructure in the standard shell based approach. That means you can simply create your resources using your simple bash commands. So all the folks who are familiar with the Linux or Unix based environments, you must be familiar with how bash works, right? In the similar fashion, Azure CLI will work. So Azure CLI will give you the look and feel of how a bash system looks like. So you can right away specify your commands and get your items provisioned or get your commands executed, and whatsoever instructions you want to perform, you can do it. So let me see, I'll just quickly show you as well. So this is the Azure portal, and you have both the ways in which you can leverage the Azure CLI. First is from the Azure portal itself, you can open the Cloud Shell, or you can also integrate your Azure CLI from your command prompt. So here I am not very sure whether you would be able to see my command prompt or not. All right. So this is how the Azure shell looks like. Now in this shell, you can switch from Bash to PowerShell. You get this flexibility. Or you can also use shell.azure.com. So for instance, let's say you do not want to work on this screen where your portal is open, you want to keep it separate, then you can go on to shell.azure.com, which will open the dedicated shell for you. Here, as you can see. Now currently I am in bash. This bash is Azure CLI. So for example, I'll just quickly show you one or two of the commands. Easy account show. So now what this command will do is it will simply show me which account I am currently logged into. So this is how simple it is to utilize your Azure CLI. So Azure CLI gives you all the flexibility of a bash system. So you just have to specify your commands and you can get your environment provision. And you can integrate it with your Linux based environment. So you can integrate it with your shell scripts or bash scripts so that you can cater to any other complex use case. So you can leverage the power of your bash scripting along with the Azure CLI in order to provision your resources. So Azure CLI is very easy to use. You do not require any additional scripting language knowledge in order to understand the syntax. It's pretty simple in itself. There are quick and easy commandlets that you can directly use and you can very well automate. All right. Now, since it provides you out of the box commandlets, right? So in those commandlets, you have to specify what you want to perform, what operation you want to do, and that is the reason it does not independently provide you the capabilities to cater to any complex use cases. In those complex use cases, as I mentioned, you either have to integrate it with your bash systems where you'll be writing bash scripts which would be taking care of your complex logics, and Azure CLI can work in conjunction with your bash scripts in order to provision the infrastructure. So this is how your Azure CLI works. Now, the second item in our list would be Azure Resource Manager. Now, Azure Resource Manager is Azure's native solution. Azure CLI, Azure Resource Manager, Azure PowerShell, and Azure Bicep. These four are the Azure native solutions that you can use with Azure out of the box. You do not have to provision or install any other component in your system. So you get all those items out of the box. So the next thing is Azure Resource Manager. Now Azure Resource Manager plays a very crucial role in terms of provisioning your resources in Azure. And how is that? I'll just quickly show you. So let's assume this would be the resource group where we will be provisioning our resources. And I want to provision a virtual machine. I am the user. And this is my Azure Resource Manager. So whenever a user triggers any operation onto Azure, that operation goes via the Azure Resource Manager and then finally the resource or the service is provisioned. Operation to provision a VM. Alright, so as you can see, the operation which the user has triggered is the operation to provision a virtual machine. However, this operation will not just directly get executed. This operation will first go via the Azure Resource Manager. And Azure Resource Manager is responsible for actually provisioning that resource. So a Azure Resource Manager is the primary component that is responsible for actually provisioning your resources in Azure. And Azure Resource Manager templates helps you leverage this Azure Resource Manager. So whenever you are working with your Azure Resource Manager templates, right, or ARM templates as we say, these templates follow the JSON format. So everything that you write would be in the JSON format. So I'll just quickly check if I have a sample to show. All right, I have. So I'll just quickly show that. Alright, so let me just see if my screen. Okay, currently it's just the window. I'll share it again. Alright, so now this is how your ARM template looks like. So this is one of the ARM templates that I had created. And what this ARM template will do is this ARM template will provision your storage account for you. So this is how your entire ARM template looks like. And as you can see, it is completely in JSON format. So there you will provide all the required parameters for the resource that you want to provision. So as you can see in the storage name, I have provided the maximum and a minimum character length as well. There I have specified a value. And then in these queues, I have specified all the available SKUs where you can choose which SKU you want to apply the resource for while you are provisioning the resource. So this is how you create your ARM template. So it's completely in JSON format. Since it is the same format which Azure uses in order to provision the resources, it is compatible with most or all of the resources that you have to provision in Azure. It is very powerful in terms of provisioning your resources or managing your infrastructure in Azure. One limitation that it holds with it is since it is JSON and with complex logics, JSON can get one level above the complexities. So it gets pretty complex in order to handle any tedious workflows. So the complexity increases whenever you are working with a bigger infrastructure. So currently here you are only provisioning the storage account. That's why it's pretty simple. However, if you have to use it for multiple different resources, so ARM templates can get a bit complex to manage. So this is how your ARM templates looks like. And then moving on ahead, next we have PowerShell. Now, just like our Azure CLI, PowerShell is also the command line utility that you get in order to provision your resources or manage your resources for Azure in an automated fashion. And as I told you earlier, in this Cloud Shell, you get the capabilities to switch from Bash to PowerShell and vice versa. So currently we were in Shell, that was our Azure CLI. Now if we want to move on to PowerShell, we can quickly switch and now we will be presented with our PowerShell format. And this is how your PowerShell screen looks like, and it is completely in conjunction with your standard PowerShell commandlets. So the syntax, the format, everything that it will follow is on the similar grounds as you have for your standard PowerShell commandlets. So just like you are provisioning your resources using Azure CLI, in the similar fashion you can provision all your resources using PowerShell as well. Alright, now since it is also the command line utility, so managing complex use cases becomes a bit tedious with Azure PowerShell and the standard PowerShell as well. Just like Azure CLI, where you were combining the Azure CLI functionalities with your Bash scripts to cater to your complex workflows, in the similar fashion for PowerShell, using the Azure PowerShell commandlets, you can combine it with your standard PowerShell scripts in order to cater to any complex workflows. So using your PowerShell scripts, you can manage the logic for your provisioning, and the Azure PowerShell commandlets, you can provision your resources. So you can do it. However, since it is PowerShell, so it is restricted to Windows based environment. So whenever you are having a Windows based environment, PowerShell is a great option. PowerShell is a very strong and very powerful tool to manage your Windows based infrastructures. So if you're having a Windows based infrastructure, then you can very well go ahead with Azure PowerShell. And combining it with your standard PowerShell scripts, you can cater to and manage any different or complex workflows as well. Now, the next component in our list is Azure Bicep. Now, as I told you guys earlier, Azure Bicep can be correlated to as the Azure's version of providing you with all the Terraform related capabilities. So the syntax, the approach in which Azure Bicep works is pretty much similar to how Terraform works. So I'll just quickly show you that as well, how the Bicep works. So this is a Bicep module. So I'll just show you with a simple script. So as you can see, it is also declarative in nature, just like Terraform. So you just have to specify your parameters, and then just like Terraform, where you provide your resource and the name of the resource and then all the details, in the similar fashion, on the similar grounds, you operate in Azure Bicep as well. So as you can see here also, I have provided you with the resource block, then the name of my block, and then finally the resource which I would be provisioning. So unlike Terraform, here you have to specify the fully qualified name of the type of resource, the resources API that you want to invoke. So here I wanted to provision a resource group. That is why I was using the complete API for that resource group, Microsoft.resources slash resource group, and then the version of the API. So this is one difference which you will see while you are using Bicep as compared to Terraform. Right inside your block, it would be pretty similar to the folks who have used Terraform. So you will find it pretty similar in nature. You will specify the name of the parameter and then value, name of the parameter and then value. So it is very simple to use. It is very user friendly since it is related to Terraform as well in terms of how it functions and how you write your scripts. So people who are working with Terraform or who are familiar with Terraform would find this execution or this transition very easy to manage. Plus, you can also have your parameter values stored in your parameter files. So as you can see here, I have created a parameter file where I am specifying all my parameters. All right. So in this parameter, I can specify my parameters. And just like Terraform, you can create your modules as well. So you can create your modules and then just call those modules just like your Terraform. For example, this is a module that I had created for provisioning a virtual network. So here, as you can see, I am specifying the virtual network name, that too using the variables. All right. And then I am provisioning my virtual network, and here I am specifying all the parameters inside my resource block. And now in the main wrapper file, what I am doing is I'm simply just invoking my VNet module. So it is pretty simple to use. It has a very similar syntax as compared to Terraform. You can create modules, you can segregate your variables file, and since it is an Azure native solution, so its integration with Azure is very good, and it will provide you support for all the major services that you have to provision in Azure. Plus, it will also get all the latest update that come in Azure, so you will be up to date unlike any other third-party tool. So that is one more advantage that you will get if you opt for the Azure native solution. So this is how your Azure Bicep works. The only limitation that currently Azure Bicep has is, since it is pretty new in the market, it's hardly 2 or 3 years old. So because of which the community is not that broad, and that is why when you will go on to searching for any issues or any errors, or if you go for any troubleshooting, right, you might find some limited number of resources. However, it is now growing. So the community for Azure Bicep is also growing. So going forward, the community will grow and you will see more articles, more documentation around how Azure Bicep function, and while you are collaborating into the project. So this is how Azure Bicep works, and this is how you can leverage Azure Bicep in your Azure infrastructure provisioning. And now the final component that we will be discussing is Terraform. So Terraform is the most common cloud provisioning tool that we use in the market. It is pretty mature in terms of integration with various different clouds, and with Azure as well. The integration of Terraform is very good. You can provision most of the resources, almost all the resources via Terraform directly in Azure. So you do not have to worry about any sort of limitations in order to provisioning of the resources. You can easily provision the resources using Terraform, and the integration is also very good. So Terraform is an open source infrastructure provisioning product that you can use to provision your cloud infrastructure and automate it any which ways you want. So in Terraform, it also uses HCL HashiCorp configuration language, which follows the similar syntax as we saw in Azure Bicep. So I'll just quickly show you that Terraform script as well, how it looks like, so that you can correlate it as well. So for example, there I have certain set of Terraform scripts created. Hmm. So for example, this is one wrapper which I have created for provisioning the application gateway in Azure. So here, as you can see, it is also following the similar syntax as we have in Azure Bicep. So you can see it is relatable. So if you are working in Terraform and you are migrating to Azure Bicep, your transition would be very smooth. And if you are working on Azure Bicep and you are transitioning to Terraform, your transition would be pretty seamless because both of these technologies follow the similar syntax. And this is how your Terraform file looks like. So this is the HCL format, HashiCorp configuration language format, where you specify your keywords, name, and then all the details. So this is a module wrapper where I'm invoking all the modules. So I'll just quickly show you how the module looks like. So I'll show you the VNet module itself so you can correlate it easily. So here, as you can see, we have the resource block, and inside it we will specify the name of our block, what we will be provisioning, and then the name of our resource block itself. So this Azure RM virtual network will invoke the virtual network API. So this is a keyword which you have to use based on the resource which you will be provisioning. So since I was provisioning a virtual network here, so that's why I used Azure RM virtual network. So just like in Azure Bicep, where we are specifying the complete API name, here Terraform has wrapped those API names under various different captions which you can use. So for virtual network, it is Azure RM virtual network, and then name of your block. So by this name, your block would be identified in the entire code base. So whenever you want to invoke or refer to this block, you will use this name in order to refer to this particular block. And as you can see, you have your parameters defined along with the values. Now Terraform also provides you the capabilities of variableizing your entire components. So all the values here I have variableized in another variables file, variables.tf, and in this file you can declare all the variables. So you have two different options. One is of your variables.tf, the other option is for your tf-vars file. So in some cases, usually what we do is we specify all our variables in our variables file, and if required, we provide some default value in this file itself. And then while we are referring to these modules or while we are invoking these variables, at that time we specify the values. However, in some case, we want it to be completely dynamic in nature. That means I do not want any interference or any manual entries in my wrapper files as well. So there what we do is we specify something called as the tf-vars file. So I'll show you one tf-vars file also. So I have the application gateway open, right? This is the final wrapper. And here, as you can see, we are referring to the modules, but still there are certain values which are referring from the variables file. So I'll show you the variables file here. So here, as you can see, we have the variables file, and in this variables file we have defined various different type of variables and how these variables function. And then we have something called as the tf-vars file. Now in this tf-vars file, you can see we are specifying the values for our variables. So here, as you can see, the resource group name is coming from my tf-vars file, and in this tf-vars file I can simply refer the values into my wrapper or my Terraform file. So this allows you to provide all the values separately without hampering your actual wrapper code. So in this wrapper code, we will not be specifying any values manually. We will be referring those values. So which becomes easier to manage as well. So for example, if I have to provide the address range multiple times, I'm provisioning multiple subnets. I'm provisioning multiple virtual networks. There I have to provide the address range. So instead of manually entering the address ranges again and again, I can provide my address range in one TF-VARS file, and inside that TF-VARS file, I can refer the value in my wrapper anywhere I want to. So I have to change my value only at a single place, and the change would get reflected onto all the places where that particular value is being referred. So this is the structure how Terraform files work. Then you have a file called the providers file. In the providers file, we would be providing the details of the cloud provider on which we will be provisioning the resources. Since our provider is Azure, so that's why the name of the provider is Azure RM. And in order to communicate or authenticate with your Azure environment, Terraform requires your subscription ID. Subscription ID is the account on which you will be provisioning your resources. You have your client ID and client secret. Now, Azure has the concept of service principals. Service principals are nothing but your managed identities which you can use in order to log in or perform certain set of automated operations. So there you do not get the interactive login options. These are more like your command line users that you can use in order to perform any sort of automation operations. So we won't be diving into service principles and all the other components in detail. So this is just a gist of how service principal works. Then we have the tenant ID. Tenant ID is the primary account under which your subscription is present. So under one particular tenant, you can have multiple subscriptions. So you can take tenant as your parent and subscription as the child accounts. So tenant would be your parent account, subscription would be your child account. So inside one tenant, you can have multiple different subscriptions. So this is how your provider file looks like, and this is the function of your provider file. Then variables.tf we have discussed how it looks like. TF-VARS file we have discussed how it functions. We have discussed our wrappers. So this is how your file structure in Terraform looks like. Now Terraform functions in three simple operations. First and foremost is your Terraform init. Now Terraform init is required every time you are provisioning or you are creating your environment for the first time. So first of all, we have Terraform init. Now what the Terraform init will do is Terraform init will initialize your entire infrastructure, your entire provider, so that it can authenticate with your cloud provider. All right. So here it will authenticate and gather the details of the cloud provider. In our case, it would be Azure. All right. So once we have performed the initialization, once we have initialized our Terraform, then you do not have to perform this command again. So once you have initialized, then you can directly go ahead and perform your executions. You don't have to initialize every single time. Then the next item that we have in our list is Terraform plan. Now Terraform plan is a very important functionality that Terraform provides. Terraform plan is a sort of dry run that you perform in order to provision your environment. So before actually performing the operation, Terraform will give you a complete and a detailed plan of what all resources you are going to provision, what are the configuration of those resources going to look like, and if your current operation will result in any sort of deletions or not. This becomes a very handy feature when you are working with your production environments, because sometimes what happens is when you are creating a new resource, so it in turns have to delete a certain set of resources, because of which it can impact how your functionalities will happen. So this dry run is very important and comes in very handy when you're dealing with your production grade environments. So as soon as you execute your plan, what it will do is it will provide you with performs a dry run and provides you with the blueprint of the environment. Alright, so this is what your Terraform plan will do. Plus, it will also tell you if there are any syntactical errors in your code base. So you will get all that visibility from your Terraform plan. So it's a very handy and a very useful feature. You should never perform the exact Terraform execution without first executing your Terraform plan. So this is something which you have to keep in your mind, because it's a very handy feature and it helps you avoid any sort of catastrophes in your environment. And once you are done with your Terraform plan, you can see that the dry run was successful. All the resources are going to be provisioned as per your requirements. Then finally, you just provide your final execution. All right, then you can go ahead with the last stage of your actual Terraform execution. All right, so what your Terraform execution will do is it will take this plan as your input. So you can provide your Terraform plan as the input for your execution, and then it can use that plan file as the blueprint and create the resources exactly in conjunction. So as a best practice, you should always provide your plan file as the input for your actual Terraform execution, because it saves you from any sort of abnormalities to happen. Ideally, when you are performing your plan and then you are performing your Terraform execution, in that scenario, usually you will perform these operations in conjunction one after the other. However, just in order to avoid any 1% of abnormalities, it's a good practice to provide your Terraform plan output file as the input for your actual Terraform execution. That is your Terraform apply. All right, and in your Terraform apply, you get the functionality or you get the flexibility to provide the manual approvals. So for example, you are provisioning your infrastructure in Azure in a production environment, right? So in the production environment, ideally you would not want anybody to directly execute the infrastructure provisioning. There you want some sort of validations, some sort of sign-offs or approvals. So there you can use the by default feature which Terraform apply provides you. So if you will not provide the auto approve flag, so without the auto approve flag, every time you execute your Terraform apply, it will ask for your approval and only then it will perform the execution. Otherwise, it will not perform the execution. All right. So there we have our infrastructure. So it will provision. It will provision the actual infrastructure. And if you provide the auto approve flag, what the auto approve flag will do is auto approve flag will skip the approvals. Consider the implementation auto approved. So let's say if you are working in your lower environments or you are testing or validating some way, services or functionalities, there you can utilize the auto approve functionality where it will not stop for any manual approvals or any manual confirmations. It will directly skip the approvals. It will consider the execution as it is auto approved and it will simply provision your infrastructure. So it will skip all the additional approvals required. And this is how the life cycle of your Terraform execution functions. So these are the primary stages in your Terraform execution. However, when you are working with your automated infrastructure provisioning, ideally this would not be enough in order to get that complete optimization in terms of your infrastructure provisioning. So while you are provisioning your infrastructure, you need multiple different components incorporated. So in order to optimize your entire infrastructure provisioning, you can incorporate different stages, different components that Terraform offers. Now, as I mentioned, Terraform is pretty mature in the market. That's why Terraform provides you with more capabilities that you can incorporate in your infrastructure provisioning. And some of those features are your formatting, linting, and cost projections. So these are some of the features that Terraform provides you. So whenever you are provisioning your infrastructure via Terraform, so ideally it's a good practice that you set up a pipeline for your entire infrastructure provisioning. Due to the lack of time, I won't be able to show you any demos in this session. However, yes, we have already done a detailed workshop on how you can provision your infrastructure in Azure using Azure DevOps. So you can refer to that workshop and you can get a good understanding. So I can also do another dedicated session on how you can provision your infrastructure in Azure using Terraform, and how you can set up your pipelines in Azure DevOps using your Terraform. So in order to provision the infrastructure, you can integrate it with Azure DevOps. So in Azure DevOps, you can create your pipeline, your complete infrastructure pipeline that will take care of all these components as well. So in your pipeline, you would be having your Terraform initialization, then you can have your formatting. So what formatting will do is, formatting will ideally format your code base. So instead of you worrying about the format or the readability of code, Terraform takes care of it, and Terraform ensures that your entire code base is well formatted. All right. And then we have our linting. So linting your Terraform files help you ensure that whatsoever code you have written is correct syntactically, and you do not have any issues whenever you are executing your code base. All right. Performs the checks on your code base. And now finally we have the cost projections. So in cost projection, this is a very handy tool that you leverage with Terraform. What this cost projection tool will do is, it will provide you the detailed breakdown of your entire cost that you will be incorporating in Azure when you are provisioning that particular resource. So before actually performing or before actually provisioning the resource, you will get the detailed insights, a detailed report of how your infrastructure would be affecting your cost expenditures. So it will give you a detailed report of all the resources that you are planning to provision along with their hourly and monthly cost. Plus it will also provide you the details of how much in total you will incur in the cost as a additional expenditure. So this is a very handy tool, and this is a very handy step which you should incorporate in your IAC pipelines. So it provides you the visibility of cost incorporated with the infra provisioning. So these are some of the very handy and very useful features that you should have. So ideally you should not just write your Terraform code and then start provisioning your infrastructure. As the best practice, ideally you should keep your code base, your Terraform code, in the version controlling system. And for version controlling system as well, you can leverage Azure DevOps, since Azure DevOps provides you a one-stop shop for your CI/CD and your version controlling systems. So you should have your entire code base in your version controlling system. So the developer would be pushing the changes in the code repository, and then you should have a automation server or automation tool which can provision or enable you to automate the entire process in an optimized fashion. With Terraform, you can automate the infrastructure provisioning. Now, in order to execute your Terraform, in order to provision these services, or in order to invoke your Terraform, for that component as well, you can have the entire automation defined in the form of your infrastructure pipelines, or we call it IAC pipelines. All right, so for that you can use Azure DevOps. So Azure DevOps will integrate with your code repository. Since code repository can also be managed in Azure DevOps, so that integration is very seamless. Plus Azure DevOps is the component of Azure itself. So its integration with Azure is also very seamless. You do not have to worry about the integrations. All right. And in your pipelines, you can very well automate and streamline the entire infrastructure provisioning process. So in this fashion, you can automate and very well maintain the entire provisioning of your infrastructure. And this is how you can leverage the power of Terraform and Azure DevOps in order to provision and manage your infrastructure in Azure. So using the Azure DevOps pipeline, you can incorporate all the different stages which I had elaborated to you earlier. So in total, you can have all these stages. You can have your initialization, then you can have your formatting, then you can have your linting. Post that, you can have your plan, which will give you a dry run. Then you will have your cost projections. And finally, once you are happy with the projections, you have a complete visibility of the environment, then you will finally execute your application of the environment and it will finally trigger the provisioning of your infrastructure and you can have your infrastructure up and running without any manual intervention, plus in a seamless fashion, and you will have complete visibility, complete control of your environment. So going forward, this is how you can leverage your Terraform or ISE approaches in order to provision and optimize your infrastructure provisioning in Azure. So with this, I will mark this session as closed. So I am open for any questions, any queries that anybody might have. So you can just put it on the chat or you guys can connect with me on LinkedIn as well. I am active on LinkedIn, Twitter. So anywhere you want to connect with me, Naveen Verma. So Sarthak, over to you.
Thank you, Naveen. It was a wonderful session. Again, uh, I watch almost 20 plus session of yours, and every session is unique and yet excited. So thank you for joining us today for Azure Serverless Day. It was an amazing learning from you, and yeah, thank you. Next we have Shafreen with us. Today we'll getting started with Ballerina. Yeah, in this session, we'll deep dive into the Ballerina, a cutting edge integration and orchestration platform that can reverse, revolutionize your integration workflow. We'll explore the fundamental of Ballerina and highlighting its powerful features such as service designers, data mappers, visual diagrams, and how it is simplifies complex integration tasks, including on Azure. So, hi, Shafreen, how are you?
Hi, I'm good. Can you guys hear me?
Yeah, I can hear you, and I hope audience can also hear you. Yeah, audience can also hear you.
Okay, then I'll start with the session. I hope you guys enjoyed the last two session. I'll try my best to make this a interesting and fun session as well. So in this session, we'll be discussing about Ballerina and its support for Azure Functions. So let me start with sharing my screen. Okay, so I have shared my screen. So let me open up the slide deck. I hope you guys can see the slide deck.
Yes,
All
I
right,
think.
so can you guys see the slide deck?
Yes, we can.
Okay. So first of all, I'll just introduce myself. So my name is Shafrin Anfa. I'm the lead Ballerina Standard Library developer. I've been working for the Ballerina team for like 5 years. So before that, I've been working as an integration engineer for WSO2 ESP team. So overall, more than 10 years of working experience related to WSO2 ESP product stack. Okay, so this is me trying to pull my best move in the desert. I know I look a bit ridiculous here. So that's about me. And here, so I'll just give a quick introduction about Ballerina. So Ballerina is about integration. So what we mean by integration is, in very simple term, it's about connecting multiple endpoints and doing something meaningful. So that is integration. So Ballerina is all about integration and how to simplify integration. So if I move further, here you can see a detailed introduction to Ballerina. So first of all, it's an open source cloud native programming language optimized for integration, as I mentioned earlier. Since it is open source, if you guys are interested, you guys also can involved with the designing and implementing process. Everything is in GitHub. So if you are interested, just let me know. And then this programming language is developed by WSO2 since 2016. So it's been a while uh, since we started implementing this. And then the first release is done in February 2022. So that's the major release. And from that point onwards, we've been adding, uh, updates to this major release quite frequently. It has a rich ecosystem. So there are a bunch of network protocols like, HTTP, GraphQL, uh, WebSocket, WebSub, and the list goes on. And then apart from that, to handle different data types like JSON, XML, EDI, there are a bunch of libraries, and Ballerina type system itself can handle many of the data types. And if you want to connect to multiple endpoints, like for instance, Azure Computer Vision, Azure Service Bus, Azure Event Hub, all those endpoints are available as connectors in Ballerina standard library. Apart from that, to edit the code, you can use VS Code. The interesting thing is, apart from just writing the code, you have a graphical visualizer as well. Like, you can write the code and then immediately visualize it using the graphical editor. And then, of course, if you want to do minor alterations, you can do that using the graphical editor as well. It has built-in efficient concurrency management system. When you talk about integration, you talk about services. So when you talk about services, you have to talk about concurrency aspects. So if you try to do concurrent programming in a generic programming language, it's difficult, to say the least. But when it comes to Ballerina, it has inbuilt features. For instance, when you write a program, compiler itself will guide you on how to do concurrency properly. So I'll get to those details later. So that's about a quick introduction about Ballerina. So in this presentation, there will be two parts. Part one is about why, what, and when. And then part two is a demo to validate and solidify what I explained in part one. So let's start with part one. Why? So the first question comes to your mind is, why Ballerina? Why do you need another programming language? So let's try to answer that question. So to answer that question, we just need to take a look at the recent history of integration. In other words, connecting multiple endpoints to do something meaningful. So it actually, started with DSL and ESP. So when I say DSL, it is domain specific languages. For instance, in WSO2 ESP, you have Synapse, which is, which is an XML based language. So if you start with DSL and ESP, they are good at simple integration. You can easily drag and drop different components and quickly do a integration. And if you go to the second point, they're good at being actually that should be, they're bad at being, actually they are good at being non-developer friendly. Like, if you are not a developer, you can just, drag and drop things and get things done. But they're bad at complex integration. When it comes to complex integration, DSL quickly falls apart, and you will have to use the underlying general purpose programming language to complete your integration. It is bad at being developer friendly, as in, if you have some programming background knowledge, you would find it easier to use a programming language instead of trying to drag and drop things. And lastly, it is bad at independent development, deployment, and scaling, which is a common industry need. This is not possible with ESBs because it is a centralized server where you deploy different integration from different teams. Because of this centralized server, it is not possible to independently develop, deploy, and scale. So those are some of the problems we have with DSL and ESBs. So if you go one level below, then you'll see like general purpose languages and frameworks. Because of the limitations because of the problems I discussed earlier of ESPs and DSLs, people thought of using something like a general purpose language with some frameworks. For instance, there are popular frameworks in Java, .NET, even in uh, JavaScript. So they thought of using one of those frameworks to do the integration. But if you look at those things, they are actually good at being developer friendly, obviously, because if you are a programmer, you would find it easy to work with those things because they are also all you have to do is just programming. They're good at independent development, deployment, and scaling. So you can directly write a service and deploy it. You don't have to have a centralized server to deploy your integration. But they're bad at simple integration. They are bad at complex integration as well. Why? Because these are not products developed for doing integration. These are products developed for doing some backend service, but not for integration. And lastly, bad at being non-developer friendly. So, if you are not a developer, as in if you don't have any programming language background, you would struggle to work with these things. And then if you move further in the timeline, then we come to Ballerina. So as you see, in both of the previous solutions, you have some problems. So these problems are addressed in Ballerina. So if you take Ballerina, Ballerina is good at simple integration as well as complex integration. So as I mentioned earlier, so Ballerina is a programming language for integration. It has uh, improved type system to describe data, and then it has concept of services. It has the concept of concurrency, and then there are features to visualize and do visual based data transformations, which I'll be explaining in the demo. So like first, there are a bunch of features to make integration simple. And it is good at being developer friendly because if you know any programming language, you would know most of the Ballerina as well. So you don't have to learn anything new, unlike using a DSL or some other ESP. So it is good at independent development, deployment, and scaling. Just like the previous technologies, in Ballerina also you can just write a service and then directly deploy. You don't need a centralized server like ESB. It is bad at being non-developer friendly. So that's like the downside of Ballerina because if you don't have any programming language background, you would have some learning curve when working with Ballerina. So this is not specific to Ballerina. This is specific to any programming language if you are a non-developer. Again, I'm saying this in the context of integration because in the context of integration, non-developers are used to using something like a DSL and a drag and drop editor. Okay, so that is Ballerina. That is why we came up with Ballerina. So in summary, like, if you take DSL plus ESB, they are like inadequate because when it comes to complex integration, they quickly fall apart. If you take the second solution people were using, general purpose languages plus frameworks, they get the job done, but they are inefficient because they don't have any abstractions or any features related to integration itself. But if you take Ballerina, it manages to solve all those problems. So it has an efficient way of doing integration because of its integration rich features. And then also you can just independently develop, deploy, and scale like the industry need at the moment. So let's see why Ballerina is efficient. So the point is like if you are a person with some programming language background, you would enjoy programming with Ballerina, especially doing integration. Okay, let's see why this is efficient. All right, so this basically again explain what I said earlier in a different way. So I'm just gonna skip that part. Okay, so if you ask me, I would like to say Ballerina is about clean and lean integration, and you'll see why in a moment. Okay, so that's about why part of Ballerina. So let's see what part of Ballerina as the next section. So, so, so what do you get when you use Ballerina? So, as I mentioned earlier, Ballerina is a programming language. So, if you look at the characteristics of Ballerina, you'll see it's cloud native, as in, you can quickly write a service, generate Kubernetes or Docker related YAML files, and deploy it in the required environment. For instance, you can deploy it in Azure Kubernetes cluster. So you don't have to deal with YAML files or anything like that. It'll be automatically generated for you, and then you can generate like smaller image sizes, have better startup times, better memory usages, that kind of stuff. It has a flexible type system, as in you can use the type system to describe inbound and outbound data quite easily. So if you take data, you know that there can be default values, optional fields, that kind of stuff. All those things can be easily expressed using the Ballerina type system itself. And as I mentioned earlier, it has nice features to do concurrent programming. Again, like data oriented is related to flexible type system. So I'm not going to explain it again. As I mentioned earlier, it has a graphical aspect as well. So you can design the service using the graphical UI, and then you can do data manipulation as well using the graphical UI. And the last part is it allows you to write reliable and maintainable program. Because of these abstractions, you can easily write a readable, reliable code so that you can easily maintain. So those things you'll see when I do the demo. All right, so and then when it comes to writing the code using the Ballerina programming language, you'll be using VS Code. There's a plugin for VS Code. You can use that. And then for version control, you can use anything you want, but popular version control is GitHub. Just like any other code, you can manage Ballerina code in GitHub as well. And since this is a programming language, you can get use of GitHub Copilot as well. So I have actually installed GitHub Copilot. So when I'm doing the demo, you'll see that Copilot is suggesting multiple lines. And then once you write the service, if you want to deploy, you can deploy it in Choreo, which is another technology provided by WSO2. So Choreo is running on Azure. It is a platform to uh, manage and run services. All right. So as I mentioned earlier, this language has a graphical aspect to it. Like when you write the code, it will generate the sequence diagram for you. So here you can see there's a main program which connects to GitHub and do something, and then it again connects to G Sheet and append new values to a sheet, and then eventually it exits the program. So this is the main program. On the left hand side, you can see the code, and on the right hand side, you can actually visualize the code in terms of what is happening. So this is quite useful because in the world of integration, we'll be connecting to multiple endpoints. So ability to visualize what are those endpoints and how you are connected to those endpoints is quite useful. Okay. And again, it has an integration design, so I'm not going to explain it here. I'll explain it while I'm doing the demo. And as I explained earlier, it has a rich Ballerina library as well. Like, there are multiple Ballerina libraries you can use to develop different types of services like REST, GraphQL, gRPC, WebSub, WebSocket, and the list goes on. And then you can connect to multiple endpoints using different types of connectors. Here you can see a snapshot of data transformation in Ballerina. So it is quite common to transform one set of data to another set of data. So you can do that simply by connecting fields via the UI. You don't have to do any coding or anything like that, and then you can simply transform the data from one form to another. So in the demo also I'll be showing how to do this. And then if you want to persist data, there's a rich way of persisting data. You don't need to worry about database or anything like that. You can specify the relationship of data using Ballerina itself, and then automatically generate the database tables and start using it. Just like any other programming language, you can do any debugging as well. And if you take a look at the application architecture view, like this is like one level above, as in when you have an architecture which has multiple services, you can just see how these services are connected to each other using this architecture view. So this is again the architecture view. Like, if you click on one particular service, you can see one level below. At resource level, you can see what's going on. Okay, so apart from that kind of tools that are associated to VS Code, there are a bunch of other tools as well. Like you can use the OpenAPI tool to generate client and service skeleton. Of course, you can do it other way around as well. You can write the Ballerina program itself first, and then generate the OpenAPI specification if you want to. Similar story applies to GraphQL as well, and again for Async API also the similar story applies. And then for stuff like debugging and all, you can just use the stand up and get the runtime information and check what's going on. Apart from that, for healthcare sector, there are a bunch of tools as well for Fire and HL7. And then in the business world, you would quite commonly come across tools such as EDI. So Ballerina also has a tool for that to handle EDI data formats. Okay. All right. So then that's about the development of services. So when it comes to deployment, there are a bunch of things as well. So as I explained earlier, like when you do bal build, what it generates is a jar file. You can directly deploy it to any runtime you want, or you can just generate a GraalVM native image instead of generating a jar file. So the advantage of generating a GraalVM native image is that the generated Ballerina program will be quite small. It will has really fast startup time, and then it will have better resource and CPU usages. All those things are quite useful when you deploy something in Kubernetes. So if you want to build a Docker image, as I said earlier, you can just do build minus cloud equals Docker. It will directly generate a Docker image for you, so that you don't have to deal with the YAML files. So if you take Docker plus GraalVM, you can, as I mentioned earlier, it is like a match made in heaven, I would say. Like, if you take the Docker image, it will immensely reduce the Docker image size, and you can have like amazing startup times, and you can have better memory and CPU usages. So, if you're deploying Ballerina programs in some Docker or Kubernetes environment, you can of course think about compiling it into GraalVM. Again, like like generating Docker artifacts, you can directly generate Kubernetes artifacts as well, so that again you don't have to deal with YAML files. You can directly generate those YAML files and apply those YAML files in the relevant Kubernetes environment. For instance, something like AKS. Okay, I guess this is more relevant to today's session as well. Like in the last sessions, uh, presenters explain how you can use Azure Functions. In Ballerina also, you can use Azure Functions. If you ask me, obviously I could be biased as well, but Ballerina has better support when it comes to writing Azure Functions thanks to its language features. So when it comes to Azure Functions, these are the supported uh, triggers and bindings. So here we have a better table. So we have implemented Azure Function support using Azure custom handlers, and at the moment these are the triggers and output and input bindings Ballerina Azure Functions support. Okay, then when it comes to observability, just deploying your service is not enough. Not sometimes, all the time. You just need to know what's happening in your runtime. So to observe those things, you can use popular things such as Jaeger, Grafana, ELK, that kind of stuff, and get uh, metrics about what's happening in your runtime, like TPS, latency, CPU usage, that kind of stuff. Again, distributed logging is part of observability. If you want distributed logging, that also possible using the ELK stack. Okay, so by now I think you have a good understanding about Ballerina. Therefore, the answer for this is quite obvious. So when to use Ballerina? So if you look at this, you can see, like, if you are a developer and if you want to do integration, Ballerina is the choice for you. You will enjoy doing integration if you use Ballerina. So I'll explain why in the demo as well. Okay, so that's about part one. So let's move on to part two, where I do a demo and explain further about Ballerina. Okay, so in the demo, what we're going to do is we'll start with a simple social media REST service. It's not a real social media REST service. It's a simple one, but it is good enough to learn about Ballerina. What we are going to do is we'll add a new resource to it, and then we'll offload some of it work to Azure Functions. So that is what we are going to do. So let's see how it goes. So usually when I do live demos, I get into trouble. Let's see if that happens in this case as well. So I'm going to stop presenting for a second. And I'm going to open my VS Code. Okay, so let me start presenting again. Okay, so can you all see my VS Code?
Yes, we can.
Okay. So let's start with a simple Ballerina project. So I have already created the Ballerina project. So let me show you what it does. Right. So this is the Ballerina service. So if I click on, so first of all, as I explained, I have already installed the Ballerina plugin. So if you are working with Ballerina, you'll have to install that as well. Here you can see the Ballerina plugin, which I have already installed. So if we go back to our Ballerina project, here you can see a simple Ballerina service. So if I just click on this icon, and if I click on my service, which is social media service, here you can see what it does. So it has multiple resources to get users and then get a particular user. You can create a user using the post, you can delete a user as well, and then you can get posts related to a particular user. So when you think of this service, just think of something like Twitter. Okay, so if I just click on one of these, you can see what are the return types for this get resource. If I just click on this, now you can see the sequence diagram for this service. So this for this resource actually. So this resource is a pretty simple one. What it does is it talks to the database and get the relevant data. So same goes to other resources as well. So here you can see the response types. There are multiple response types. If you click on here, this resource is a bit more interesting. So here you can see what it does is it talks to the database and query some data, and then what it does is it handles the if there's an error, it handles the error and send back user not found if the user is not available. If not, it continues with processing, and then eventually it again talk to the database to insert some data and send it back to the client as a response. So this is the visual diagram. So if I just go to the code, here you can see code is very simple. Like, it all it does is it connects to the database and gets some data. So if there's any error, it will handle the error. Otherwise, it will simply send back the data. So all these resources are very simple. All it does is it talks to the database and pulls some data. So if I quickly show you the ER diagram of the database, so database is already running in the background. And if you look at the database, it has post table, users table, and followers table. That's all it has. All right, so let's run this service and see. So here you can see VS Code is compiling the program first, and then it will start running the program. So in the meantime, here you can see this is the Ballerina project. There are multiple Ballerina files. So you can define Ballerina files here and then start writing your program. Here you can see this is a service. So this is how you write services in Ballerina. And you can give the base path as you want, and then you can specify whatever the paths you want. Okay, the service is running. So let's just send some request and see if it is working. Let's try to get the user. Okay, here you can see we can get user details if we just click on like something else. Okay, it works also. Here I just wanted to create a new post and I just got 201 created. So it works. So now what we are going to do is, so by the way, to send requests, I'm using REST client plugin in VS Code. Okay, so now let's say we just want to add a new resource with these requirements. Say I just want to get post for a particular user, and the URL should be something like this. Since I'm doing a query, I should use get, and then the response payload should be something like this, a JSON payload, and the payload has details like ID, description, tags, category, that kind of stuff. All right, so here I have just mentioned the database queries that we need to execute just to save time. So let's try to add this resource to our existing service. So let's go back here and let's go to Visual Editor. Just make it bigger. Right. Let's go to our service and let's click on Add Resource. All right, the path should be, as I mentioned earlier, users, and I just want to add a path parent. So this is how you add path parents in Ballerina. Type should be int and the name, let's say ID, and then we can just say post. Okay, so I don't want to add any other parameters, and then as the response I just want to say 200. Okay, and then the response type should be post. So I haven't created it, so let's quickly create that response type and get back to this. So first thing we need to do is so this is the response which we need to create. So let's use that example response payload to create Ballerina record type. So what you can do is you can just copy the response example response payload and then just do Control Shift P if you are using a Mac, and then you can say Ballerina paste JSON as a record. So that will create the Ballerina records required to describe the response type. So in Ballerina, to describe data, you can use something called records. It is pretty simple, like, record is a collection of different types of fields. So I don't want this. So let's name this as post. And then this one, maybe we can say created date. Okay, so we have our data type. So now what we need to do is we can just go back to our design view, click on our service, add the new resource. I'll just quickly go through because we already did this. Int ID post. And then as the response, what I want to send is 200. Okay. And the type here, now we can see it has listed the new type, which is post. And I just want it to be an array. Okay, so all good. So we can just create the new resource. And if you go back to your code, you should be able to see the new resource. Of course, you get a red line because we haven't implemented the body of the resource. So now what we can do is we can quickly implement the body of the resource. So first thing we need to do is we need to talk to the database. Here, as you can see, like, since I'm using Copilot, it automatically suggests what I want to do. So I'll just use Copilot suggestions and do some changes. So here the query is actually wrong. So the query which we need to execute is this one. So let's use that. So what it does is when we get the request, we just do a select operation against the post table. And then we just pass the ID to filter out the response. And here what we need to do is, what I expect is something like this, post, or there could be some error. And I just need to give the variable name. I'll just say post. Okay, then we can just, since there could be, so in Ballerina, you can use union types. Here what it says is like you can get a post array or you can get an error. So I don't mind what it is. I just want to return whatever I get. So I'll just say return post. And from here also we can just say this service returns an array of post or an error. So if it is an error, Ballerina will automatically handle that error and convert that into a HTTP response. Okay, so all good. So I'll just stop this service, save it, and I'll just say Ballerina run offline. So just to save some time, I'm just using the offline flag. Okay, the service is started. So if I try to send a request now, so this is the new resource we just created. So this is the URL of the new resource. So if I just send a request, okay, I get internal server error. Okay, so here I just need to do a quick change. So, as I said earlier, there can be hiccups. That usually happens when I do demos. So here I'll just take the type from here. So the type should be, so here the created date should be something like this. So let's use that instead of using this. Okay, so let's try to run the service again and see if it works this time. Let's make sure we have saved it. Okay, service is running. So let's try to send a request again. So this is the resource. Okay, this time we get the required response. Here you can see for user 1, we get user 1 has done 2 posts. One is this, the other one is the other one. So now you get the response. So what happened is actually when you here when you do if you go to this resource here, you can see I'm querying the database and getting some response. And that response, what happens is that database entries are mapped to this data type. In this data type, so in the database we have date type. So to match to that, we need to use date type here as well for created date. Okay, so that's that. So now let's say, before we move on to that, I just want to quickly show you guys here. So I have created a MySQL client and initiated that client. All the configurations are externalized in the config terminal. You should be able to see like connection details and everything. So I'm using that client to connect to the database. Okay, so if we just visualize this, here you can see the visual diagram for this as well. So again, it's a simple one. What it does is when the request comes in, it talks to the social media DB and get the data and send it back. Okay, now let's say for some reason, front-end team wants to change this response into something else. So let's say, let me use split screen. So let's say they want something like this. So here you can see the response is now different from the previous one. The content is almost the same, but here you can see when it comes to tags, in this case tags are under meta, and we have a proper array of tags instead of just comma separated values. And then if you go further, you can see category, created date, all those things are under meta. So let's say for some reason our front-end team wants to change this payload into this one. So let's see how we can do that. So to do that, what I'm going to do is I'm going to leave this service as simple as possible, and I'm going to offload that CPU bound operation into one of the Azure functions. So let's see how we can write Azure functions in Ballerina. So let's just quickly create a new folder here. We can say map post to post with meta. So we already have that folder, so I'll just create meta1 folder. Okay, so if we just get into that folder, let's open this one. Okay, so I just opened a new VS Code. I hope you guys can see the new VS Code. Okay, so here, if I click on Azure, you can see I have already logged into my Azure subscription. So my Azure subscription name is this. So let's give it a minute. So under function app, I have already created a function app named post to post with meta. So now what I'm going to do is I'm just going to create a new Ballerina project. So let's do that. So if I just do Control Shift P, I can go to this command, which is Azure Functions create new project. So if we click on that, you can select the new folder, and then here under technologies you want to use, you can use a different languages like TypeScript, C#, Java. Under that, you can see Ballerina listed as well. So I'm going to select Ballerina, and then the runtime is JVM. The trigger is HTTP trigger. I'll just leave the name as it is and then hit enter. Anonymous is what I want to use. Okay, so now it is creating the project. So you can see it has already created the project with a sample template. Okay, so as you guys saw earlier, here also it creates a service, and this is the HTTP listener which maps to HTTP trigger. Right, so now what I want to do is I'll just quickly so the new payload structure we want is this one. So using this, like I did earlier, we can quickly create the Ballerina data types. You don't have to do it manually. You can just do this and it will create the required Ballerina records. So I'm going to say this one post with meta. You have created date, so that we can just say create a date, and here I'll just quickly copy it. Okay, so it's there now. The other thing I just want to do is the inbound payload is this one, which we need to convert into something else. So instead of creating it again, I'll just copy it from here. For this, I'll just use this one. Okay, so now maybe we can call this convert, and then we can just say something like convert post to post with meta, something like this. Inbound is going to be a post, and the request, the data type I'm expecting is something called post, something like this, which I want to convert. And then here the response is I'm expecting I just want to send post with meta array. So inbound is also an array, response is also an array. So let's fill in the body of this thing. So let's see how we can transform post into post with meta. So to do that, I'm just going to create a simple function. And if I just click on visualize, I'll be directed to the data mapper. So let's just name this as map post to post with meta, and then the input is a post type, which is an array, and then the output is post with meta again, which is an array. Okay, so let's save it and continue. All right, now here you can see the input and output types. I can just do this. Yes, obviously I get a red line because it is, you can't directly map those things. So what you can do is you can use the suggestion, and then if you just go one level below, now you can see the input type and the output type details. You can just map one by one because they are direct one-to-one mapping. But when it comes to tags, you can see the type of tag is string in this case, but here is an array of string. So when you try to connect that, it will just give us a red line. So we can quickly fix it with the expression editor. So here what I want to do is I just want to use the regex. So if I go to libraries, it will list down the array of libraries. I just want to use the regex library and do a string split. So there are a bunch of functions available on the regex. So I'm just going to use split. So when you click on that, it will show the description and other stuff. So here you can quickly just give what you want. So what I want is to split by comma. And then if I go back for the second parameter, I just want to give post dot text. Okay, let's save it. Okay, now that part is also okay. Now we can just map category to category and create a date to create a date. Okay, looks good. So if we go back, now we can see the function is automatically generated for you, so you don't have to do any programming for doing data mapping. Okay, so now we can I'll just say, as I said earlier, so Copilot will be suggesting stuff. So in this case also it's suggesting what I need to do. Okay, so it looks good. So if I just try to build the function, let's see how it goes. So you can see it is being built. Let's give it a moment. Okay, so the function has been built. So if we just run it locally using this command, let's see what is the output. Okay, so I'm just running it locally to try it out. Okay, the function is started. Let's copy the URL and let's try to invoke that. So I have a sample request already, so I'm just going to use that here. So invoke the Azure function. Okay, so we get the expected response. So you can see the data is transformed as needed. So here this is the input payload we sent, and this is the response payload we get. So we get what we want. So it looks good. So let's go back and deploy this in our Azure environment. So let's deploy this. So I'm going to use what I have already. Let's click on deploy. So if I click on output, we should be able to see additional details. So you can see it is being deployed to Azure function app I have. Let's give it a moment. It says deployment successful. So I should get a URL soon. Query triggers. Let's give it a moment. Okay, so it is being deployed. So now I get the new URL. Let's try to invoke this. So earlier I was using the local one. Now I'm going to use the one deployed in Azure Cloud. Right. Okay. Again, as in the local environment, we get the expected response from Azure Cloud as well. So if we go to the browser, so here, if I go to my home under this resource group, let me just zoom in. So I can see my new Azure function. So if I just click on that, you can see the details. So I'm not going to go into these details because these details were explained in the previous session. So we have just one last thing to do. So if we quickly go back to our VS Code, now what we want to do is go back to our service. Right, now here, what we want is, instead of sending post, we just want to send post with meta. So I'll just quickly copy the data types. Because I generated here, I can just simply use it directly. So this is not needed as we have already defined it. So here now for the response type, we can just use post with meta. Now what we need to do is we just need to invoke the service we just created. Let's say post with meta. You might get some error. So for this we need a HTTP client. So I'll just quickly, maybe I'll just create it here. Let's create HTTP client. Final HTTP client Azure endpoint new, and the URL is not this one. I'm just going to give what we used here. So let's just use this one as the URL. Okay, I have my HTTP client. So now what I'm going to do is I can just use check. Okay, so I'm going to use the HTTP client to invoke our Azure service. So here what we can do is equals Azure endpoint, and I'm just going to do a. So here the URL that I need to invoke is the rest of the URL we can just get it from here. It is this one. You can just directly give it here, and then I'm just going to send post this one and hopefully get the required response. So here instead of just I'll just get rid of the error and directly send it here, and then what I'm expecting is this one. I'll just again return it as it is. So when I do a HTTP call due to various network failures, there can be errors. So if there is an error, I just return that error as well, and then HTTP listener will automatically handle that error. Okay, it looks good. So let's try to compile this service. Not this one actually, so I just have to go back, go to social media demo and say run offline. Okay, the service is started. So this time to invoke the service, I can use this one. Okay, I get the response, and here you can see the required changes are done. Now I get the meta tag, and the meta tag I get the required information. So if I quickly go back to the service and click on the visual diagram, and if I just click on the service, so this is the resource we just created. If I go into that one and click on this, now you can see the interaction of each endpoint here in the visual diagram as well. So here you can see first we do the database call to which is called social media DB, and then get the data, and then we do a post to Azure endpoint and get the information and send it back. So that's all it does uh, in this function. Okay, so that's all I wanted to cover in the demo. So due to the time limitation, I just skip certain things. However, if you are interested in learning more, what you can do is you can just visit to this link. So if I just click on that, there's a YouTube playlist which explains how to do integration with Ballerina part by part. So you can go there and learn further if you want to. Okay, so I'm right on time. So if you have any questions, obviously you can reach us via one of these social media channels. We would be more than happy to help you guys if you guys have any questions. Okay, so that's the last slide deck I have. So I'm right on time. So I don't know if you have any questions. Maybe you can ask now.
Thank you, Shaprin, for the wonderful session. I learned something new today with my audience. So I guess audience doesn't have any doubts. But can you share your all the social media links over the WhatsApp group as well, or over the chat, so that if anyone have any doubt or if they want to learn something new in Ballerina, they can.
Sure. So are we sharing the slide deck as well? That also has the
What
information.
I can do is you can drop me a mail. I can share it with community once after the session.
Perfect.
Be okay. Thank you everyone for joining us today. You will find a PPT link and all the social media account which Shafrin shared over the description in next till EOD. And thank you for coming to this session. It was a great session with all of you guys. Thank you so much for joining us. Thank you. Thank you, Sachin. Yeah, we are planning for more such sessions, more hands-on. This is just an introductory session of Ballerina and for Serverless State, but we are planning for more such sessions. Thank you everyone for joining us today. Bye bye and see ya.